the first points I'd like to make, and I'm only going to do this once, but I do want to point this out. Hacking as a activity isn't inherently malicious or evil. Hacking is a terrific sort of mindset, and lots of cool things and cool people hack. But I'm only talking about malicious hacking. I'm not going to say that every time I say the word hack, but obviously that's what I'm going to be referring to. And in focusing on malicious hacking, the first things people, I think, need to keep in mind is that this is not a side effect of the computer revolution. Hacking predates computers and will outlive computers. And hacking, because of the incredible reward and incentive for successful hackers, in fact, drives more technical innovation than it impedes. So if it's not your business, it's pretty much nothing but an impediment, preventing bad actors from disrupting, your good work. But in fact, because it drives so much innovation, because the rewards are so high, pretty much no matter how large your organization is, no matter how well educated your people are, you're almost certainly outmanned and outgunned. And so the only way to effectively, long-term, mitigate the risks from attacks is through healthy, deep communication with peers, and also with collaboration with third parties whose focus is preventing those attacks, right? So, hacking drives innovation in some way, both by trying to crack into places where bad actors shouldn't go, but also in preventing that. So you have this cat and mouse game that drives innovation. And so collaborating with those folks will be critical. You simply can't catch up. So we'll talk a little bit about that. So let me just defend or explain those points. So going back 115 years, Marconi, who famously, invented, wireless communication and transatlantic communication, he announced that he had established the first true confidential communication channel in February of 2003. And he traveled to London to demonstrate his incredibly secure wireless communication. And it took exactly 4 months for a competitor to hack to figure out, the wavelength he was using, frequency, and hack into it. And in public, he hacked into it, was typing in profanities and insults. And his motivation, Neville, was he was a competitor. And Marconi had done a great job with getting patents and effectively locked him out. And so this type of strategy of hacking to disrupt operations, to steal data, ultimately for commercial enterprises, in fact, well before any computers that were around. And Neville's other claim to fame is that I believe he invented the pay toilet. That's just a piece of trivia for you. So Neville was, in fact, very ingenious, I suppose. Fast forward about 100 years, a couple of TJ Maxx, fairly large data breach at the time, and it's notable for a couple of reasons. It got a lot of popular press. It's sort of the first time in public that somebody declared this data breach to be the worst ever, right? And a few tens of thousands of records. How quaint, right? But it was in fact very important because it also was the first time that hacking was really directly and forever forward connected with broad risk management practices and principles. It moved from just sort of a technical, good housekeeping type of thing to prevent people, from hacking, to being a part of a broader corporate risk management. How could you have allowed this to happen? Didn't you take precautions? They said, well, we did do that. We encrypted our data on the wire, we obfuscated our code, but it turned out they didn't do it consistently, right? And that's really where it registered that, this has to be part of a policy, part of a control. That control has to be tested, and people have to be educated, and you have to certify all that. So that's really why it became clear to everyone that just handling it as a technical issue was never going to be sufficient. Now, hackers, as I say, continue to evolve, and just to call out a number of I think, sort of milestones. In 2016, somebody hacked into a medical device, and they found that this particular pacemaker had a controller, an external part of the device, that by hacking into that device, by sending malformed packets to a pacemaker, they could force it to run its battery down more quickly. They could also drive other types of potentially very dangerous behavior of that pacemaker. So rather than sort of following good hacker etiquette and contacting the development team and telling them about the vulnerability and hopefully getting some sort of bounty, instead this hacker raised some VC, shorted the stock, and then announced the defect, and the stock plummeted. There was no criminal charges. There was a couple suits back and forth, but it was settled. It was a legitimate business model. So now, if you're a public company, realize that if a vulnerability in your software can be used to create some sort of liability, one strategy that maybe not even your competitor, right? This is not a competitor, will use is to short your stock and ultimately decimate your company. Another, sort of milestone is the idea of tampering with applications inside networks. And this was documented. One stark example of this is in primarily in Russia, but it's starting to move into Eastern Europe. People have been able to modify ATM software so that, say, at 2 p.m., these ATMs start spewing out cash. And so now who's the criminal, right? I'm standing in front of an ATM. Now I just happen to have been notified by my criminal boss to be there at 2, but you can't prove that. And so I'm just there catching money, right? So that's a whole other level of hacking. And again, just to sort of, this is actually this week, scientists that showed with mice that they can hack into a brain, right? And they pick little nano this or that, some modified DNA, but they can hack into your brain and change how you move. So certainly hacking will survive or outlive computers. So what does all this mean if hacking is this huge innovation driver that sort of transcends the software we develop? Well, one of the first places you see that are in regulations. And so I'm going to make a few more assertions that regulations that are coming fast and furious are simultaneously outdated because nobody can write, so legislation cannot possibly be written at a cadence that software can be written, but it's also aspirational. So it uses out-of-date terminology and concepts and to then articulate a series of obligations and liabilities that in fact are aspirational. And so what that does is it directly wires a whole new level of penalty and risk to your development, DevOps, and ALM practices by directly connecting financial and criminal penalties. Okay, so with that, so taking that point one step further, the only way to not just confront hacking as a risk, to manage the regulatory obligations that are coming, cross-functional communication within your organization and collaboration is the only way to manage this. And we'll talk about how technical terms are showing up in regulations and legal obligations and requirements are showing up or should be showing up inside application specifications. In 2016, the Defend Trade Secret Act was signed into law in the U.S., and there's a sort of an equivalent or a close equivalent in the EU, a directive around trade secrets. The key point here is that when they define the crime, right, the acquisition of a trade secret is by somebody, through improper means, right? The improper means is the key phrase, and then of course the law goes in to define what improper means. And one of the little sections there, says what improper is not. Right? It explicitly says reverse engineering is equivalent to independent derivation. So this is actually a very common notion. So if I buy a wallet or a watch on the street and it's mine, I bought it, I'm allowed to take it apart. And patents notwithstanding, anything I learn is mine to reuse in any new business, right? It's totally okay. So to a lawyer, seeing that phrase means nothing, right? To a developer, where reverse engineering obviously has a overloaded meaning and implies that I can look at source code, and that sometimes I reverse engineer for very good reasons, for debugging, for training, for interoperability. But what it says here is if you think the fact that you give somebody a binary and that by implication you haven't given them your source code, nothing could be further from the truth. You've given them your source code, okay? And other aspects of the law that are key are that in order to get any of the protection under these regulations, a trade secret has to be secret, and it has to be secret from cradle to grave, meaning you can't for a few months have treated it as not a secret and then decided it was a secret. Too late, right? And what does that mean, keeping it a secret? Well, again, very common notion or construct. The courts will say, well, did you take reasonable precautions? And what does that mean? Well, it means, what are your peers doing? What do people do in similar situations? And they use that benchmark. And that's going to turn out to be very, very important as we step through what obligations are expected of development and DevOps teams. So the key here, one of the key high-level takeaways, is that technical requirements are increasingly showing up in legislation. So in the past, your legal team or your risk team would say to your engineers, just don't do anything dumb with our IP, and that would be it. And it'll be up to the engineers to know what that means on any given day, year, or decade. But at this point, there's now in the law saying reverse engineering is allowed. So that's a technical requirement. And you're seeing that we see that a lot. So that's just an example. Coming in May, it's already been passed, so it's sort of a 17-18 thing, is a massive piece of legislation inside the EU. Now, for those of you who are not calling from Europe, don't put me on mute and start checking your email because the enforcement is global. So if you have European records flowing through your business, or European records of your customers are flowing through your business or your software, you are vulnerable or you are exposed. And no size business is exempt. And penalties can be exceedingly high, up to 20 million euros, or whatever's higher, 4% of your revenue. And what's also unique about this law is that it includes data processors, meaning if you are say a service provider, you have a cloud service, and some of your customers are passing their data through your service, unbeknownst to you necessarily, quite possibly, your subject, and your suppliers, and part of that standard is that you then have to have a solid supply chain. So if I control private data, if I process private data, or if I'm part of a supply chain to one of those two categories, I'm potentially liable. Okay? So there's no distinction between protected data and the processing software, right? And so therefore there's software development wherever and whomever builds it can be found equally as liable, right? That's a precedent. and beyond. Okay, so this is not a law, not a regulation. It's at this point just guidance, right, around principles of vehicle for smart cars. Okay, and it's the same kind of thing, except what's interesting about this, and again, in the follow-up, I'll send you links to the actual regulations and some more detail on how specific terms and sections map exactly to the kinds of to these points that I'm making. But what's interesting about this is that the standards have been extended. And actually, I skipped over that in the GDPR. Actually, I do want to say that the standards are high. This is actually really, really important. They don't say reasonable, like the trade secret. Like you might take reasonable precautions to secure your data. What they say explicitly is you are on the hook to know the current state of the art. So that means controls or precautions that you put in place 2 years ago, if they become obsolete or vulnerable, you are now on the hook again. So you have to track, or maybe you look to experts and third parties to do that for, to help you with that. But state-of-the-art expectation, both in terms of knowing the threat and mitigating those threats, is significantly higher standard and a significantly higher commitment beyond the reasonable clause. And so, again, looking to peers and experts will be critically important. And so what the cyber vehicle guidelines did that is I think notable is it takes all of these concepts we've just talked about people who own data and process data, transfer data, and the liability of all the stack and the people that are part of that workflow. They extend it up a supply chain, and they extend it up into equipment manufacturing, and they extend the quality and the integrity standards that are GDPR focused on data. They focus it also on software and equipment quality because it ties to safety, right? And the other thing that I think is interesting, and I'm pointing these out because I think these are clearly trends that we're going to see repeated over and over and over again. And so if whether or not you're an industry-focused development team or a horizontal, a broad use case development organization like we are, you can't ignore these trends because they're going to show up over and over and over again. And the final point there is it's sort of nice. You see this increasingly at the end of these recommendations. They provide a very nice list of all of the computing and industry standards that they use to derive their recommendations. Right. So and again, I'll send those along. But the idea here is you're seeing a commonality, both in terms of how you're expected to assess the risks that you face, as well as the types of controls and frameworks that you'll be expected to use, or at least deliberately not use for cause. I mean, if that makes sense. But you not making a decision is a decision at this point. In 2015, it was reported that Anthem, had a ton of data stolen, and we're not going to go into the mechanics of all this. The details are not so important, other than it was quickly pointed out by Anthem and by others that they adhere to the letter of the regulation, HIPAA privacy regulations. Here's the letter of the law. They did not violate a single thing. There were plenty of recommendations, plenty of things that are left up to the discretion of each organization to do optionally. And I'm not speaking for them, but it certainly appears that whenever there was a choice about something being optional or required, they went for, thanks but no thanks. We take it seriously. We're going to follow the rules, but if we don't have to do it, we'll see, right? Throw it in the backlog. Except what happened was, and this has been called out in why these are all external sources. But very quickly, somebody said, well, gee, you had a whole bunch of companies of similar size that were being attacked with a means that HIPAA doesn't require that you defend against, right? You didn't have to encrypt your data specifically, right? But not encrypting your data turned out to be a wide open door, and it was being rapidly documented. And oh, by the way, law enforcement said, federal agencies said, by the way, your industry is being targeted. So again, no law was changed, no regulations were changed. And so what happened was, because they didn't benchmark, because they didn't stay state of the art, they didn't get punitive fines, but they were essentially told to spend about $260 million upgrading their systems. And I'm guessing they weren't in a great negotiating position, so they probably paid retail for everything they had to do. Interesting quip from the Info Security article, where one of the consultants said, and I quote, "I expect other healthcare organizations to take note, right? And hopefully they'll, again, what are your peers doing? Watch your peers." And so you thought, okay, well, that's the end of it. The $260 million, no punitive fines. Unfortunately, all of their, clients and suppliers got together and took them to court in civil litigation. And so then they had to settle another $115 million on top of that. So because they didn't benchmark, because they didn't take a formal risk assessment of the app on a continuous basis versus just saying, what are my obligations under the law? Well, it cost them about $350 million. Right? So let's not do that. So with that in mind, this is an output from the NIST, federal U.S. agency, tracks documented, reported vulnerabilities in commercial software. Okay, and so this is looking at over 4 years, 5 years, and they categorize vulnerabilities into categories. And I pulled out a couple: bypassing some logic, executing code without permission, access to information that normally you shouldn't be able to see, escalating privileges to walk around somebody's software or data or network, interrupting operations. So you can see that these vulnerabilities are numerous, and for the most part, they're increasing. Okay? Now, going back, say, to that medical device, the St. Jude's example, where you send certain types of malformed packets, right, which drove unauthorized or unauthorized behavior, right, of that software. How do you think they figured that out? Right? They didn't just think about it. They didn't just start randomly generating packets at a random device. They probably minimally maybe reverse engineered the code to see its logic. More likely, they probably found a way to monitor the network and the software, maybe attached a debugger to that software, right, to see its execution, what it was doing. And it turns out the reason these particular vulnerability categories are identified, or here, highlighted, I should say, is because while a debugger, in production, attaching a debugger in production, or monitoring behavior, or reverse engineering, are not actually part of the vulnerability itself or the exploit itself, it almost certainly was the means through which the hacker identified the vulnerability, which allowed them to exploit it. And since it is impossible to guarantee that you will write bug-free code or vulnerability-free code, or that you can prevent your data from being visible at any time during its life cycle. So that would be ideal if you could do that. That would be the best, right? But you can't do that. So in addition to trying to introduce no vulnerabilities and trying to cloak and encrypt and shield your data wherever you can, you also need to take steps to prevent this well-known, well-understood, common means of attack, okay, against applications whose risks, whose exploit, whose subversion would cause you great damage. Obviously, there's certain apps, who cares, right? So that's the whole risk assessment piece. But the notion that only focusing on data and not on the integrity of the application, not just how you write it, but how it will run in production, even if written well, that cannot be ignored. And if you think, well, I'll wait until something happens, again, the precedent as to what happens when organizations ignore federal reports about trends is fairly high. Okay, so in order to secure customer data, the applications that process that data must also be secure. It shouldn't be hard to assess the risks associated with the compromise or subversion of your applications, right? And I'm not going to step through sort of a risk 101 in the session because we start to get into the technology and the controls. But a couple of things that are worth pointing out, which is, sure, you can find, I'll just use the reverse engineering or the attaching of a debugger to an app, right? That's quite common, well understood. So that's a gap, right? That could be exploited, but who cares, right? And so then you say, well, okay, is there a vulnerability that if somebody did it in a particular context or a particular time, they could do something bad, right? And part of deciding how important it is its materiality, right? It's a way of talking about that. And one of the key things that around materiality is how likely an exploit is to occur, right? So the material, like if this happened, oh my God, that would be terrible. But it's 1 in a million chance that this exploit could be taken advantage of. Okay, well, that's different than if you know it's going to happen. It could happen every day, right? So what's the likelihood? And again, that's where benchmarking, that's where communication is going to be critical to understanding those requirements. So we're going to sort of skip over that for now, but obviously the goal here is not to eliminate all risk, but just to take material risk, ones whose likelihood multiplied by severity is unacceptably high. What do you have to do to make them acceptably high? One of the things we did, and we'll send you some of these results, as well as give you an opportunity to benchmark your own practices against these results. We completed a survey, I think at this point it's still less than 2 months ago, where we had 400 development organizations answer, a variety of questions about where they see risk, how they prioritize that risk versus other risks, and how deep do they invest? So you might say, oh, there's a risk of somebody reverse engineering my software, creating a competitive product, and going to market and hurting me in some way. Well, if you're an equipment manufacturer and software is just a piece of that, it's a little less likely, right? Because they need the equipment along with whatever software. So it could be a risk, but it may not be a high priority, or even if it's the same priority, it may not justify actually investment. You just live with it, appetite for risk. And so what we found, it's not surprising really, but so the top 6 risks categories from all respondents are here, and hopefully you can all see that. So data loss or corruption was number 1, not a surprise. IP theft, again, you guys can read this, I'm sure, quicker than I can speak them. But this is all 400. What was interesting, though, and maybe not surprising, but to really look at the data, is that when you looked out by industry, so manufacturers who built software as part of their operations versus, say, financial service providers who develop their own software as part of their operations, not surprisingly, perhaps, their priorities change. So they agree on the priority, but for example, financial services agreed that data loss was still number 1, right? Whereas manufacturers care about data loss, right? But not as much as they care about intellectual property theft, right? So understanding the priorities by industry can be very, very important. And we also measure in the survey that what degree, like how important, right? So there's a weight that is calculated. Again, when I send you the link, you'll see more of this detail. But you can see, for example, one thing I found interesting is for development organizations, regulatory and compliance was the least important of the top 6. So it's not that they didn't say it wasn't important. It's just it didn't ever rise above the other 5. However, when you looked at the weight of those in the development organizations, there's a marked difference, right? Healthcare developers, even though they would say it was number 6, were put a much higher value on regulatory and compliance requirements than generic non-ISVs, non-software development companies. And financial services also put a high priority on compliance and regulatory obligations. Interestingly, software companies were significantly lower than the norm. Okay, again, not saying that they don't care, but they valued it way less or prioritized it at a much lower level. Okay, so understanding, again, your peer group has a couple levels. Now, we also asked, what types of controls do they have in place? Okay, and again, we saw something interesting. So again, you see the segmentation by industry. So overall, you see that 65%, let me take a step back and just explain the graph a little more. Controls could fall into 4 categories. Preventative controls, so around that development, that could be the obfuscation, where I want to prevent someone from reverse engineering software. Detective controls, so I want to detect if I'm running my Android app on a rooted device, or if my my desktop app is attached to a debugger, if I've been tampered with in any way, shape, or form. There's a defensive or responsive control, meaning, okay, I've detected I have a debugger. What am I going to do about it, right? And reporting. And, you could say response could include reporting. It certainly could, but reporting is more of a roll-up. It has more to do with risk management and auditing and things of that sort. So we asked, do you have controls in any of these 4 degrees for to prevent reverse engineering, to prevent application tampering, and to prevent, unauthorized debugging, attachment, monitoring, modification of data or code. So a couple of things to point out. In terms of a general practice, more than half of respondents do one or all of these things. Okay, and so that's fine. So just number 1, and in terms of detective and responsive and reporting controls, you start to see different levels of investment, but still more than a third in most cases do report that they do something to detect, defend, or report when these things occur, right? But here's what's interesting. So you do see that, for example, manufacturers have a different perception of risk, and so not surprisingly, they have a different investment in mitigating those risks. But what's also interesting is how ISVs fit into this. ISVs, while they have their own unique requirements, like worrying about software piracy, for example, tends to be a much higher concern than other industries for the most part, they also tend to take on the risk profile of their target users. So looking at, for example, we segmented them this way, an ISV, a software development company that builds software specifically for manufacturers, right, actually start to look more like a manufacturer's risk profile than, say, a software development company that's selling a retail application or a consumer-facing game or something of that sort. So if you're a software developer on this call, you need to not only be looking at your peers, so what are software development companies doing, but it would be, I think, well advised to be tracking the evolving risk profile of your target markets as well, because you may be surprised that they value or prioritize things differently. And again, some of this is obvious and intuitive. So if I sell software into a hospital, I'm going to hear about HIPAA requirements all day from my buyer in the hospital. But it becomes more subtle. What is a reasonable control? What type of response? What type of attacks? What are the how important is compliance in one area versus another? Well, that will correlate obviously with the materiality or the risk that your target markets are facing, and those clearly shift. Another metric that was interesting to see is that focusing on industry, yes, if I'm a software developer, what industries I focus on, okay. The other is, irrespective of any of that, larger development organizations take on, and therefore would be expected to, manage risk more comprehensively, more consistently, both, right? So they tend to apply more controls, right? Higher percentage of larger organizations will have in place, for example, defensive controls against tampering and unauthorized debugging than smaller ones. So if you're a large company, right, a large development organization, or are you managing risk like a small one? Again, that's a potential vulnerability in and of itself. So just to sort of roll up the survey part, and again, there's lots of ways to slice this data. Overall, preventative controls, 48% did not have these in place, right? Detective controls, 65 did not. So you can read this again faster than I can. So do you need to position yourself as a leader in managing risk? A laggard? Somewhere in the middle? This is the kind of thing that a court, a regulator, ultimately investors certainly would look, auditors will look at. So which controls should you have? When should you have them? They would have all of the elements, right? They prevent things from the risk from occurring. They detect when it happens. They'll defend against and mitigate when it's happening. They will tell you when it's happening and provide the ability to document and audit, not just the state at any one point or any one incident, but aggregate all of that activity over time. But here's the key, right? Without adding, without including, creating undue additional risk from a different sort, being too expensive or requiring too much effort, right? So in other words, the cure cannot be worse than the disease. And by the way, if you read the GDPR regulations, they account for this too. I mean, they talk about, part of what they define as an obligation is to include controls that don't create an undue burden. So there's allowance for that. And so it makes sense to measure and to evaluate that. Right? So just sort of as a tying it more specifically to application development, right? Risks around hardening applications you might create defects where they didn't exist before. You might dampen or impede a user's experience. You might make it really, really hard to build, test, and deploy the software, to debug that software. Should a user report an issue. If it becomes, from a developer's point of view, really complex, and they have to learn new technologies in order to do what they were able to do the week before. These are all things that can be extremely expensive and damaging downstream, obviously. And obviously, there's the quality of the control itself. So is it reliable? Does it scale? And like any supplier, and especially with regulations like GDPR, where your supply chain is actually part of how you're measured, vendor viability, right? So these are things you want to measure against how effectively these controls mitigate, IP theft of your software, injection of malware, data compromise, counterfeiting of your software, theft of services. Again, you can read all this. So this is sort of the magic, right? And as I said, the cure cannot be worse than the disease or the placebo, right? So I'm going to just spend, I'm at my 15 minutes remaining mark. I'm going to spend maybe 5 minutes just sort of mapping our approach to this problem. And then I'll open it up for questions. So first of all, the notion of reasonable controls, right? And if you look at .NET, if you look at Java, even increasingly now iOS, there are free, widely available, and for Java and for .NET, sort of platform-sponsored free solutions to provide some level of application hardening to protect your code and the data that flows through it. So the notion that anyone could argue that it's not really a risk, or who knew it was a risk, that I think is essentially laughable, right? I mean, there's no chance you can make that argument. Worth pointing out that the .NET free solution is for those that maybe know us and be here because of your work with us around Java. We are that default solution, in quote unquote, in the box. For Java, it's something called ProGuard. That's fine. Similar in many respects. And there's an open source rename capability for Objective-C, which coincidentally we provide through GitHub. So it's widely available, it's well established, well understood. As I say, maybe worth noting, we're 2 of the 3 of those solutions. Now, there are commercial licenses, and there are a number of, obviously, there are a number of options available. We provide hardening for .NET, for Universal Windows. We just now support for .NET Core. Obviously, Java we support, as well as Android. We have a professional SKU. And what you get with all of this is additional controls, so additional corrective controls, additional responsive and reporting capabilities, and obviously, additional support and much faster cadence in terms of fixes and those kinds of things. So again, we're certainly going to cover all of those. And then when you get to true incident monitoring and defense, we can also inject the ability to do reporting, and we can connect to, it's typical, you'll connect to third-party portals like Microsoft App Insights, Google Analytics. We have sample code that can show you how to do that, as well as on-premises solutions that we can provide as well. So the idea is that we can detect one-time incidents, alerts, we can do exception monitoring, of course, but we can also capture and provide incident response framework to meet regulatory obligations about reporting as well. And by the way, the more precise the alerts are, the narrower your reporting obligations will be. And so that's going to reduce both the cost, the complexity, and the risk of being non-compliant. So that was the deck I brought today. And as I mentioned, we will follow up with an email. They'll put a link to these slides. Links to all the reference regulations that I've been talking about, as well as either blog posts or other publications or documents, I should say, mapping those controls specifically to development and DevOps requirements and practices. Provide a summary of the benchmark survey results that I've referred to for quite a bit. I do want to point out that there is look at that document. If you send an email to the address that's in that document, you can request a link and you can fill out essentially that survey behind those results, and we'll provide you with a benchmark. So you'll answer what risks you care about and how important they are, and what technologies you have in place, a little bit about your industry, a little bit about your technologies, the technology stacks you're using, and then we'll give you some contrasting data, comparable data, I should say, where you can contrast your practices versus your peers. So with that, and of course, we'll give you links if you're not currently a customer of ours, or if you're a customer of ours on on Java but not .NET, or vice versa. We'll include links where you can sort of try some of this stuff out on your own. So I mentioned early on, very beginning, a slightly different context perhaps, about what a big innovation driver hackers can be and are. And I mentioned that part of that isn't just their incentive to steal things and cause revolutions and do whatever they do. It's also that it spawns investment from people like us to defeat their latest attempts at hacking. And so there are certainly tools who try and who put out versions of their software to say unwind our current drop of string encryption, which is really string mangling. Maybe they'll figure out some of the ways we do control flow, mangle IL, and they'll be able to unwind some of the less complex algorithms that we use. And that's natural. And so one of the things we do is we track that, and we see if somebody is making progress or a tool is making progress, and then we up our game as well. So, for example, in the latest release of Obfuscator, which just came out yesterday, in fact, there are a couple of those things in there. We don't actually publish those because this is the cat and mouse game. So, we let people figure out if in fact their earlier algorithm still works. So there's a little lag time there. And that's something, by the way, to measure if you're looking at any sort of security provider, right? If you're looking at antivirus, which is a much faster cadence, obviously. If on a given day, 2 antivirus software vendors were as good, but one took 48 hours to respond to a new piece of malware or virus, whereas the alternative took an hour, obviously you'd go with the 1 hour, right? And that we need to have a larger investment in keeping up, probably not just somebody that was smarter. So we spend a lot of time doing that, but it is a cat and mouse game. Some things are lossy. So renaming, for example, you cannot figure out names. We don't use the same naming algorithm twice, even on the same exact binary, right? So some things you can't unwind, some things you can work at, but beyond the renaming thing. And I'm going to sort of then take it to another level, which is, you said you're aware of an obfuscation attack that can defeat the obfuscator. Well, okay, but you might be using the obfuscator to put anti-debugging in. You might be putting the obfuscator for anti-tamper, for watermarking. If it's a mobile device, you're checking for running on a rooted device. And so if your only concern is to protect against reverse engineering, well, then the 3 points I made are irrelevant, right? But there is, as far as I know, certainly there's no tool that point per point targets all the different types of controls we offer. And around obfuscation has been around for quite a while. Our first obfuscator was Java obfuscator in the 90s. And so this is not a new game. And so yes, they're for those running old versions of the obfuscator, perhaps, yeah, probably there are tools out there that can do a pretty good job of unwinding control flow and string encryption. Again, renaming cannot be unwound. It's a lossy transform. So hopefully I've answered your question. So another question: how do we receive these updates for your obfuscation engine? So again, I'm going to be nitpicky. The engine, the obfuscator, is more than obfuscation, right? So how do you get updates to the obfuscator, which includes the obfuscatory transforms? That's an automatic thing. If your build machine is on a network, the obfuscator checks itself: is there an update? And it does what lots of software does. Hey, there's an update. Would you like me to update myself? And you can say yes or no. We do send out emails to our registered contacts. We just had a release yesterday, as I mentioned. We tweeted it. We have a change log. You can go on our site and see the specific features and all that. But we do have an automatic notification and automatic in place update and upgrade utility as well, which works for most people, but not always. Is the auto update available? So I didn't go into, I did mention that we have this free version of .NET obfuscation. And by the way, just to be clear, even the community edition, the free version that comes in Visual Studio, it includes debug capability. It includes anti-tamper. It has support for Xamarin. It has support for well, not yet .NET Core. That's coming. It's a little behind. It is behind. But you know, we've in the last 12 months really upgraded, if you will, the functionality in that community version. So I recommend that you take it out. But so your question is, does CE automatically get updates? And the answer is no. You can come to our website and you can download CE. That if there's a newer version, but we bundle. Well, it also depends a little bit on the version of Visual Studio because they've changed the way they package. So, but generally, the answer is the version of CE you get is the version that was distributed with your version of Visual Studio. There are some exceptions to that, but for the most part, no. How mature is it? Well, I think it was the first .NET obfuscator. Microsoft was actually a Java client of ours before .NET. And so when they got ready to launch .NET, they recognized they needed equivalent hardening capability, and because we were a supplier, and I guess they liked us, we struck a deal where we built a .NET obfuscator for them. It shipped in Visual Studio 03. I think it was actually available in 02. And in addition to the thousands of commercial large-scale clients in manufacturing, and aerospace, healthcare, and financial services, et cetera, that beat it up at an enterprise level, there are literally tens, if not hundreds of thousands of developers using the free version, certainly hundreds of thousands over these years. And so in addition to whatever testing we go through to meet the, in the additional quality and smoke testing that Microsoft puts us through to remain in that coveted position, we have just a huge user base with a significant coding investment in our technology. So I would say, without question, it's by far the most mature offering in its class. I mean, it just has to be, not just because our testers are so great, which I hope they are, I think they are, but just all the help that we've had over so many years. Paul writes, if you're mainly interested in preventing reverse engineering, is CE efficient? You might have meant sufficient. Either way, efficient, sufficient, I'll answer both. The answer is it may well be, but that's not all you need. That's not the only question you need to ask yourself. CE Community Edition, like Visual Studio Community Edition, the special SKU of Visual Studio, has some different functionality, yes, but it also has restrictions in the licensing terms and conditions. So Community Edition is for individual use. So if you're a developer and you want to harden the software you've written, you personally, and you own that software, then you can produce hardened applications, sell them, do whatever you want. Okay? If any of the answers to those questions was no, meaning I'm not the only one building software, or I don't own this software, it's my employer's software, then you cannot ship commercial software protected by CE. Could you use it to test obfuscation on software? Sure, that would be that's fine if you want to understand it. So as a learning proposition, but you can't ship commercial software if it's a group effort. Okay, so that's just a licensing requirement. One thing I would recommend, certainly check it out. You can also, as I mentioned, you can download a professional SKU and run them side by side. And I don't publicize this on a website or anything too loudly, but with that 2 week, or it starts out as 3 days, if you identify yourself as opposed to using Gmail or something, identify your employer, would give you 2 weeks to use the software for free, again, can't ship production software, but with that comes support. So that live support I was just praising. If you want to really understand how to best configure the software, see if it has side effects, to understand the real value it offers, how to fit it in to your build chain, our support, test the support, use the support. So thank you all. We're out of time. As I say, we'll follow up with more material. You can send me email. You see my email on this last slide. Follow us, PreEmptive, on Twitter. Follow me. Please keep in touch. And if you're concerned about any of these particular risk categories, regulations, happy to set up a side call to drill into it. So thank you all.